Hello.
Hi.
How was your weekend?
I had a super good weekend.
Really? What'd you do?
A Halloween party, had breakfast with a friend, and then I did a little urban exploring at an abandoned GM plant. It was awesome. How about you?
I worked, and then I did nothing for Halloween except dressed up like a nerd and worked at work as a nerd. Anyway, but it was okay. I got to see some family, so it's nice.
It's fine.
Also, we officially have another seat up here that's empty. You know, someone wanted to come up closer. See over here. It's empty. That person-
Can I come up closer?
He literally just said that. Ellie. How are you?
Oh, not bad. How are you doing?
You're bad, is that?
I said not bad.
Oh, okay.
How are you doing?
I'm good.
Excellent.
I'm pretty much good. Okay, you have 3 papers on this one.
That was
Oh,
fun.
it's blank. You're just kidding.
Uh-huh.
Okay, we left off kind of looking at the real brain and kind of looking at some of the things like the soft eye and so forth. So let me put on a more diagrammatic just to kind of catch up on what we went through. You know, we identified the central sulcus, which is right there, and the lateral sulcus, and the postcentral gyrus, and the precentral gyrus. We didn't talk about lobes, you know, but the brain is divided into lobes based upon the bone that's underneath. It doesn't have too much meaning, you know, we don't normally do too much with that. And of course, we got to talking about the cerebral cortex, which is this outer layer of the cerebrum. So it's only about 1/4 of an inch wide, okay, but that's where all the higher brain functions are located. Okay, so that's kind of where we left it. So what we're going to do first is look at the functional, sensory, and motor areas. So let's use this, kind of look at this, functional, motor, sensory areas. If you were to take a line and divide the brain right through the central sulcus and the lateral sulcus, for the most part, this anterior part has a motor function. All of this posterior part has generally sensory functions. So it is more or less divided into those 2 major areas. Okay, so we're going to look at some of the major sensory areas first. Okay, the first one is the primary sensory cortex, which is the same as the postcentral gyrus. You need to know that. So it's this area right here. The primary sensory cortex. Pain, temperature, touch. Those are the sensory modalities that particular area of the brain pick up. Okay? So we're not going to do much with pain and temperature, but we are going to talk a lot about touch. So anytime you get touched on your body, okay, that's the area of the brain that recognizes where. You are aware of where you're having these touch sensations. Okay, so that's the primary sensory cortex. Each of these primary areas I'm talking about will have a association area. Here's the somatic sensory association area. You know, functionally, it just takes it up one more step of understanding. Okay, so yeah, that primary sensory cortex can say, you know, you're touching on the anterior part of the forearm. But it also tells me this next area, who is doing that and why. So it's not, it's me, I'm demonstrating, that type of thing. So it just takes it up a step for understanding. Back here is the visual cortex. Obviously, everything you see, eventually, when it gets here, that's where you actually begin to visualize and understand. It is what you see. Before that, you don't know what you're looking at. So the visual cortex, people get hit in the back of the head, you see all the stars, that's because of the visual cortex. It also has an association area, which just takes it up a next step to understanding what it is that you're seeing. Then conveniently placed, right here, is the auditory cortex, right there. So everything you hear, eventually, is going to end up there, and that is where it's converted to an understanding of what you are hearing. Okay? And there's an association area with that as well. So these are three of the major senses. There is one that's not listed up here for smell. And it's going to be right in this primary sensory cortex area right here. So there's an area for smell. What do you smell? That's where you determine where. Okay, then if you look down this area, right here, see, it's called the general interpretive area. All of these areas are listed on your checklist. And there's two brains, the ventricular brain and the dorsal brain back there that have been marked. That's what we're going to learn. General interpretive area or Gnostic area. And I've added on another term called Wernicke's area. We got three names you can use for this. Basically that is the area of the highest level of interpretation of what's happening. Okay, so all sensory information is going to end up there. Everything you see, everything you hear, at any one moment in time is gathering there. Touch, pain, temperature, even memory. Information from the memory areas of our brain. All going there, so that gives you the ultimate awareness. Everybody is totally aware of what's going on around you, what's important, what's not important. You're just aware of everything. This is the area of the brain that permits that, total awareness. Also, Wernicke is kind of going along with communication. And so in communication, you've got to have an area that you use to understand what it is you're listening to when people talk to you. That's the area that's going to pick up that. So, a general, interpretive, Gnostic, or Wernicke. Now let's move to the motor, primary motors. So again, we have a primary motor cortex, and this is going to be the precentral gyrus, which is right next to the post right there. So that's the primary motor cortex. That's the part of the brain that has the neurons that are directly hooked up with your skeletal muscles. They directly hook up with the skeletal muscles. So they go down and they obviously hit a motor neuron that's in the spinal cord and then off to the skeletal muscles. So that's a direct connection. So any of the skeletal muscles that are contracting, that message originates right here. Contract. That's all it's doing. It's telling you. Contract. Okay? There is also a motor association area which makes a little higher level of control. Actually, these two have a bit of a controlling or talking to each other really rapidly. When you type, and a lot of people can type like how many words a minute? Some of you type, you know, it's sometimes amazing how fast you can go. And immediately, you know when you make a mistake and you correct it. It's like real, I mean, you don't have to have, I mean, these two areas are somewhat connected for things like that. Okay, now there's another one, right here, the frontal eye field, up there. The muscles for your eyes you control. I can look up and down and all over around, okay? So that's skeletal muscles. But there are reflexes involved with that which you don't control, okay? For example, if all of a sudden something started happening out here and you would get gunshots, a lot of commotion out there, every one of you would be looking away there. You could not keep from it. You would automatically be looking away there. Unless you knew it was going to happen. You knew there was going to be a lot of commotion out there and knew what it was going to be, yeah, you did not know. But if you don't know, you will. Okay? It's not like you sit there and say, well, I'm hearing a lot of noise out there. It doesn't look like that. It's much faster. Okay, so frontal eye field. Okay, then we see here the speech center or Broca's area. Okay, that's Broca's speech center. It's not just really talking, but that's one of the major things. But for example, what you say, how you communicate, originates from this area. But what it's doing is telling the muscles through this area which ones are going to move, which ones aren't, which ones are going to contract, when everything goes along with all of that. So Broca area has to communicate to the primary motor cortex how to do that. The last one we're going to look at is the prefrontal cortex. Okay, so I've got like 5 words which kind of gives you an idea of the major importance and function of this primary or prefrontal cortex. Thought, intelligence, motivation, personality, and tact, TACT. Okay, all rolled up into one. So how many of you have heard of prefrontal lobotomies? Through the years, you heard those. There was a movie called One Flew Over the Cuckoo's Nest with Jack Nicholson. It was all about him getting a prefrontal lobotomy. Prefrontal lobotomies were done on criminals a lot in the past. It would take away basically their personality, their aggressiveness, and become little pussycats. Okay? Basically. There's this guy that knew how to do prefrontal lobotomies. They were called ice pick lobotomies. Okay? This is actually one being done on a 12-year-old. But an ice pick lobotomy, what you would do, you would stick this ice pick looking thing up between your eye, between your eye and the bone there, up into this part of the brain, and just kind of massacre that part of the brain. Destroy it. Okay? This guy did this back in the 30s. It's not that long ago. He was really good. He did these on people with schizophrenia and supposedly had some success.
Well,
It's sort of like
Wait,
what's the result? Like, what is
it destroys the prefrontal cortex. That's
Right,
what
so
they-
then how is the
this
person
area right
gonna
here
answer
is
that?
by squishing around there, you're breaking all of the connections, neural connections in that area. So you just,
could I see?
well, yeah, they can see. This boy can see. Okay. Well, let's go to, why did they do a prefrontal lobotomy on a 12-year-old boy? This argument came out years ago. Well, I can tell you, It was his mother-in-law. She had a lot of problems with him, a lot of complaints, but these are the three major complaints supposedly. He was very sullen. He had a reluctance to bathe. Thought he could smell. This was the worst one. He turned on the lights during the daytime. But this article, and this is showing him before and after, where they put that little needle right up and just supposedly smash. This says prefrontal lobotomy that did not touch his soul. In other words, this is the gentleman when the article came out, you know, he lived a relatively normal life, which means it wasn't a very good operation. Didn't work, okay? I have another couple show and tells today. I have another show and tell here this was a article, 26-year-old girl who was slightly mentally retarded. So her parents had to do a prefrontal lobotomy on her, saying they did not want her to embarrass the family. So they did this on this young girl. Anyone have any idea who I'm talking about? It was John Kennedy's, Ted Kennedy's, Robert Kennedy's sister. So it was the Kennedys. She was slightly retarded, so they wanted to make sure she did it. So they did a prefrontal lobotomy on her. This article was when she died at the age of 86. So for 60 years, she lived as a little infant. She had to be taken care of like a little infant because of the prefrontal lobotomy. So this one worked, okay? They don't do prefrontal lobotomies anymore, you know, but it's all about